Mike, welcome back to Talk Python to me. It's been a little while.
How you doing?
Hey, I'm doing really well. How about you?
I have a cold, but hanging in there.
Yeah, thanks for toughing it out and
Yeah.
being here with us.
Yeah.
When we last spoke, we did speak about SQL Alchemy, of course, but it was in April of 2015. That's been a while.
Yeah. So was that like version 1.1?
Something
Maybe?
like that. Yeah,
Something
yeah,
like
yeah.
that.
And that was episode 5 of the podcast that's been going.
Oh, right.
Years. So really early days. I appreciate you
Yeah.
helping me kick off the show. And can you believe it's still going? That's crazy, huh?
Yeah, doing great.
Yeah, thanks a lot.
I'm glad Python's popular enough that it can have its own podcast. I'm pretty psyched about that.
I'm super psyched about that as well. Maybe, let's sort of start with that actually. Back then, Python was already popular, right? 2015, we'd already sort of hit that hockey stick growth curve that started around 2012. But even so, does Python's popularity and growth and appeal surprise you these days?
No, it doesn't surprise me. I'm pleased that it's growing in popularity. I think the first thing that I saw about Python when I first got into it in the early 2000s was it's really clear. It's really unambiguous compared to everything else that I've used. And I always wanted to be involved with a language that quote unquote regular people can get involved with, and people at a low level, high level can do things with it. I didn't want to be focusing on a computer language that would only be very high level math whizzes, because I'm not not a math person at all. That's why I don't really do Haskell. I wanted there to be, because I worked in different jobs, and I always would be, not always, but often someone that was writing all the frameworks and the architectures, and then all the other people were using my frameworks, but a lot of those people were not at the level that I was, and I wanted to make sure that the stuff that I did was approachable. So Python's very approachable, and the fact that now that the academic world and the media news world is getting very data oriented, surprise, they're all using Python, which was
surprise, surprise.
Yeah, that's exactly what I would have expected. And it might not have gone that way, but it was a pretty good bet. So it's cool that there's a data science profession now, and Python is at the center of it. So I think that's really great.
Yeah, it makes a lot of sense that it's at the center of it. I do think it has this special appeal to people. And I think it's made up of a couple of parts. One is you can be very effective with a partial understanding of Python. Like you could not even understand what a class is, and you could still do meaningful stuff, right? Which a lot of languages don't have that feature.
Right.
It has the packages, right? All the
I
haven't even checked. Let me check it out. How many packages are on PyPI these days? 338,000. That's a few things to just grab and fill with like Lego block style, some of which you've contributed to up there. So that's pretty awesome. Some of the popular ones. I think it's fantastic. So good to see people continuing to embrace it. And you mentioned making it more accessible, right? Like there's different things of accessibility. I can write for loops and do a list comprehension, and that's pretty easy to understand. There's another, like, I need to talk to a Postgres cluster and make it do things, right? It doesn't matter how simple Python is. When you talk to external systems, you, to some degree, take on the complexity of that external system, right?
Yeah.
And I do think ORMs, and in the NoSQL world, ODMs, if you will, really democratize that as well. You can write the code in the language you already know, and it does the database stuff, including the slight mismatch of language features in SQL, like at parameter name versus question mark type of variations, right?
Yeah. Well, it's interesting, that particular variation is not even necessary. That's a quirk of the Python DB API that they decided to have different parameter styles. So we wanted to make it so you wouldn't have to worry about that. So yes, as far as democratizing, SQL Alchemy was always aiming to democratize as much as it could, to make things that are trivial and you shouldn't have to worry about, like question marks versus colon name. You don't have to worry about that stuff. But at the same time, I always came from all these different database shops where we had to use every feature possible, and it's always about exposing the database, the SQL Alchemy remains pretty different than most tools. Any tool I've seen in Python, more or less, probably tools in other languages that is not trying to create kind of this abstracted away. You can't really know that it's some vaguely relational object store thing. It's like we really want you to be into SQL, and you just happen to be able to write it in terms of Python constructs, but you can also write SQL strings. And we're going to try to get that to have as much flexibility as possible. And yeah.
That's there's a couple of interesting philosophies that around SQL Alchemy, or philosophies of SQL Alchemy that you've imbued upon it. And one of them is not to hide the database, right? Because you often end up in this leaky abstraction where it's like, oh, you can just forget there's no database. Oh, wait, is it too slow? Well, now you're into some weird world where it's not a great fit, right? So maybe we could talk a bit about the philosophies a bit before we get into what's new and where things are going.
Yeah, well, the basic philosophy has always been, and I think some years into it, I read some articles that gave me some better terminology. One of automation of working with a SQL database. Like if you're going to write an application that talks to a database, and you're going to, have 20 tables, and say you're not using any ORM, you're just going to write raw SQL. You're going to find yourself writing the same insert statement, typing it out over and over again. Like I know that my table has these 10 columns. I'm going to type this insert statement. That's what we call boilerplate, right? Any program that anyone writes using nothing at all, they're going to write some function to generate that insert statement, right? Like people usually talk about select statements as like the ones they want to have more control over, but there's just the boring ones. There's updates, inserts, and deletes, which are really boring. There's all the DDL for creating tables and stuff that's very redundant. Like nobody needs to, like if you want to learn how to do that stuff, you should learn how to do that stuff. But if you have 100 classes, you don't want to type out 100 create table statements. You don't want to have to do that. It should be automated. So the idea is that when you're working in this automated environment, you still know everything you know what a create table statement is, you know what an insert is, you know what CRUD somewhat is, you know SQL, you would know it ideally, not necessarily, but ideally you would know how to write this whole program without using anything. Like you would know how to use raw SQL.
Right. I would say probably a good rule of thumb for I've studied enough SQL to feel like I'm not hiding too much from myself by using an ORM would be if you could get the ORM to print out its statement. So in SQL Alchemy on the engine, if you set echo equals true, for example, and you know what it does when you read the statements, you're like, okay, I'm not sure I would have exactly seen to write the join that way, but okay, that makes sense. I see why I see what this update statement, these parameters mean. Okay, like now let's be productive, right? What do you think about that as a rule?
Echo equals true, all right, was when I first wrote SQL Alchemy, whatever I did for the first 2 weeks, echo equals true was right there. That was like the very first thing. Like you will see the SQL, because I had come from using, I think I probably used Hibernate for a while for Java. Now it's 20 years later or 25, Hibernate I'm sure is very different. But at that time, I didn't know how to see what the heck it was sending to the database. I had no idea. I mean, I'm sure there was a way to do it, but it wasn't like obvious. It was like you have to set up lockers and this and that and Java this and Java that. And the idea with Hibernate and other, it was like, well, you shouldn't have to know that. We do the SQL for you. Why should you know that?
Use us correctly and we'll solve the problem, right?
I want a really one-to-one thing where you're writing this Python select dot where dot whatever, and it's like what you can one-to-one. I mean, if I had more videography skills and also a lot of time, I'd make some kind of cartoon that shows boom, boom, where this, how it lines up in the statement. Because it's not meant to hide anything. It's meant to automate. So like if you had, I always use the idea of a soda bottle company, like a soda company, like you're selling soda, soda's not good for you. But if you had to bottle 4,000 bottles of soda, you would use a machine to do it. It's not to say that you don't know how to pour soda into a bottle yourself, but you need to scale it up. It's about scaling up something that is very repetitive to be typing by hand.
And be consistent, not about and repetitive and whatnot.
Yep.
Absolutely. A couple comments from the audience real quick. I just want to throw out there. D. Varazo says, hello from
Danielle.
From PsychoPG. Thank you for your kind rapping. And Jay Lee is just cheerleading for Python, which is awesome. Awesome. Hello, everyone out there.
Hi.
So yeah, I think this is really a powerful thing to think about, just the reproducibility, and also in terms of linking into the tooling. I think one thing people often miss about the advantages, because sometimes you'll hear people say you should never use an RM. It's hiding too much from you. And
yeah, sure.
Yeah, sure. Go. I'm going to go do something. You keep working on your strings. So one of the things I can see that sometimes can easily get missed is refactoring tools, error checking, right? If you write some kind of select statement on a class and you want to change that field or that column, you change the field, which obviously maps over to the column, but that also changes your entire code if you're using a proper editor that understands refactoring, like VS Code or PyCharm or something like that, right?
Yep. So a big thing with the refactoring, and one of the things that we had to adapt to as it came, was PEP 484, which is, I call it MyPy, but it's not MyPy. MyPy is a tool that checks Python annotations, and we call it the MyPy thing, but it's really PEP 484, which is that this new thing where they're trying to have a kind of a layer of typing, like a strongly typed, statically typed layer on top of your Python script. So if you're a library in Python, you have to work with the system now because people expect it. And the IDEs, I use VS Code now with I keep forgetting the name of the engine, but the PyFlakes, not PyFlakes.
Yeah.
You know what it is?
Yeah,
PyLance. I can never remember that name. PyLance. PyLance. Think of a lance. PyLance. PyLance uses the annotations a lot. So, and I actually am seeing where it works and where it doesn't work. And I think the refactoring tools are greatly improved by the fact that there is this concept of static type annotations.
Yeah.
I think there's a lot of shortcomings in PEP 484. There's a lot of things that's like, it's not great. I'm not 100% optimistic on it, but it's way better than nothing. And there's also some features that are coming that are in PEPs that have not been implemented. There's this thing called variadic types that would allow us to actually be able to type your result set coming back. If you give it a select, we'll know all the types in your result row.
I see. Is that something
possibly
like a generic or template type?
It's a generic that works like the tuple type, because you might notice in PEP 44 you can't make your own tuple type. The typing that's applied to tuple is actually, if you look at the MyPy source, it's hard coded. If equals tuple, then all these new special things. So things like that they need to fix.
Yeah.
Because rows from a database are essentially tuples.
Right.
So that's how we want to type them.
I do have a question, since we're talking about the typing. I pulled up this super simple example here off of the SQL Alchemy documentation. It doesn't really matter. It's just a class that derives from declarative base, has a table name, and then it has the stuff that people probably know from many ORMs, these descriptors, right? So ID equals a column, which is of type integer, primary key equals true, name equals column, which is a string, and so on. I'm going to tell you what I've been doing with this stuff lately, and you tell me whether this is a good idea or a bad idea or whatever. So what I've been doing is I've been writing this code as like this name one. I would say name : string equals column string. So the Python code believes it's the type that's backed by the database, the column type. So name is a string, ID : int, even though it's really set to a descriptor of column integer, primary key equals true.
Yeah.
Have you seen this? Is this a good idea?
Yes, I have done a lot of work on this concept, and what you're doing is not incorrect, but there's a lot of complexities to it that require a little more going on. You mentioned
to be clear, I'm not doing this for MyPy. I'm doing this just so my editor is more
sure. Yes, but also for the editor, I don't have the link handy. I'd have to go searching on my computer. But there's actually, so first of all, we do have a MyPy plugin where you are able to use annotations like name : string, and it will automatically kind of work them into the correct kind of thing to be recognized also at the query level. It doesn't work with PyLance, and I have a new approach that I worked out with some other people for PyLance type stuff where we won't need a plugin, where you will be able to make we're not totally sure how we want to do it. The point is that you would say name : you wouldn't say stir. You would use this other construct called mapping, or mapped rather, and mapped, and then the mapped type is stir. The reason you do that is because if you use the user class in a query, not as an instance, it also has behaviors at the class level.
Right, like .desc for descending.
Yeah, like that kind of stuff, and also
like that,
right. So I'm trying to work out the best way to do this, where you're not typing the same, you're not repeating yourself, because right now it's a little bit squirrely. The class works completely in Pylance. Everything that's expected both at the class level and at the instance level will work out. It probably requires that when you do the declarative class, you would use a slightly different API. You wouldn't. The current proposal is, instead of using uppercase column, it's this new thing called m.column. We can always change the names and how it looks. One of the flaws with that declarative model you see there is that when I came up with that declarative idea many years ago, those column objects are not Python descriptor compatible at all. They actually get replaced when you map the class. It's totally like a seal. It's not that clean. So I have ideas to make declarative cleaner, and do more of what it's supposed to do without kind of breaking the rules. That's the thing about Python, is that as the years have gone by, everyone, even newcomers, we're all much more into being clean about code and being more verbose. And typing is more verbose, and async IO is more verbose. When we were doing Python in 06, 07, everything was like, done. This magic object, boom, magic object. Like, nobody wanted to type anything. Now people, which was bad, we didn't totally do it because it was scripting language. But nowadays people are way more tolerant of more verbosity, more clarity. And I'm trying to keep SQL Alchemy and my team, we're trying to keep it going along with that. So the PEP 44 thing, 484, the async IO stuff. So that's my knowledge dump for the typing thing.
No, that's fantastic.
It's a work in progress. Yeah.
Do you think that people, I have some thoughts on this, but do you think that people are more willing to accept like a little more structure in the code now because the tooling is more there to help you write it? Like I write my maybe C tab. I don't write column of whatever, right?
Right. Maybe it's the tooling, because nowadays people use Python data classes, and they want to use Python. We have some support for Python data classes now. And the syntaxes that they want me to implement, which we've done, are pretty verbose, because they want to have a data class where you have all your data class fields, and then within the field, they want to have the mapping information. And people are like, this is awesome. And I'm like, great, because like it's actually more verbose than I would prefer, but like people are way more tolerant of that. So yeah, I guess their IDEs are spitting things out, or just people.
Yeah,
the values are different now.
Kids these days. So is the goal with the data classes to try to have a more pure entity model that doesn't have like column information and key index information, and just there's some other layer that puts those together? Or what's this? I haven't really played with that aspect.
The data classes, I haven't really had the Kool-Aid with the data classes yet. I think the idea is that it's this very clean data encapsulating object that has kind of prefab constructors and Reaper and validation.
Yeah.
Maybe
it does have that kind of stuff. That's right. Comparison.
Yeah, I might be thinking of Pydantic. I mean, Pydantic kind of takes it a little further. There's kind of some murky stuff between data classes, Pydantic, and SQL Alchemy.
Yeah, they blend together in my mind a little as well.
It's all weird, yeah. And there's a new product called SQL Model that seems to be pretty popular in that regard.
Yeah, built on SQL Alchemy.
Yeah, which is great. It's totally awesome. It's actually a more opinionated overlay of the ORM, and it's also using Python. So that's good. The thing you got on the screen there is another way of that's called a imperative table
class, but it also has the mapper registry.mapped on it, which is interesting. It has some of it. Its table metadata has like not just the table name, but all the column information as well. It's interesting. It does have the same type declaration that I was trying to impose upon the traditional SQL Alchemy models.
Yeah, that's one form of the data class model. If you scroll down, the more inline embedded one is there. Let me see if that's what it is. Yeah, that's the one that's even crazier, which you have the data class fields. So you're fully a data class as far as what your IDE sees. But then you have the SQL Alchemy mapping stuff inside. So all of this is, time will tell which approach becomes the popular one.
Yeah.
Or people just use SQL Model, because the people that like data classes tend to be using SQL Model and Pydantic anyway, and maybe they'll be there. I don't really know.
Yeah, I'm gonna talk to Sebastian Ramirez maybe in December or January about SQL Model.
Yeah,
SQL Model is interesting because it basically takes Pydantic models and SQL Alchemy and merges them together. And Sebastian has a good feel for what a nice API looks like. So I'm optimistic for this. I haven't done anything with it, but it does look pretty neat.
What he had to do was he had to modify Pydantic's base class, because when I first looked about maybe like in this past year about how Pydantic do SQL Alchemy without having two separate models, I was like, okay, this base class has got a lot of things going on that don't work with Python descriptors, so it would have to change. And I think Sebastian did that, basically. He went in and changed how the init works so that it's compatible, and more power to him.
Yeah, more power to him. Awesome.
I have enough to work on. I can't. This is like too much for me to also work on Pydantic. So I'm glad someone else did it.
Absolutely, absolutely. All right, one more philosophy thing. That is not it. This is the one. One more philosophy thing that I want to ask about, or let you just speak to, because this is a key element of how SQL Alchemy works. There's other ORMs that work this way, and then there's also this one. I think it's called Django. People might have used the Django ORM before. No, that one is more of a traditional Ruby on Rails active record, where I have a thing and I call save on it.
Sure.
You went with this thing called unit of work, which is a little more transactional. Like I'm going to do a bunch of stuff and then all together, it happens. Yeah. Maybe just speak to that real quick before we talk about it.
Well, when I was going to do SQL Alchemy, the main thing that I had worked on a lot at work was a lot of fancy selects. I hadn't done much work with the persistence side, but I read this book by Martin Fowler called Patterns of Enterprise Architecture.
I read it as well. It was quite an interesting book back then, yeah.
And I had actually never, even though I had used Hibernate, I had never heard of unit of work. And I was like, wow, that looks cool. I'm going to write that. Because, one of the philosophies was like, insert, update, deletes are really, really boring. And even saying object.save is really boring. You're going to, because I was working on a content management system for Major League Baseball. And when you work with CMSs, you have a lot of tree-based hierarchical structures with lots of self-referential stuff. When you persist self-referential structures in a database with auto-incremented primary keys, you've got to get one row, get the primary key back, put it there, then everything's got to be done in a very specific order.
Yeah. Like I tried to call save on this, but that didn't work because I needed to call save first there. And it's like, this is crazy, right?
Right. So it's like, why would I want to do, why I shouldn't have to do that either. I should just have this thing that like, here's everything in a transaction, just push it. And it, took a very, very long time to get it right. It has a couple of little chinks in the armor, a couple of cases that you might have to drop into calling flush explicitly, but we never get bugs with the unit of work stuff. If you look at unit of work.py, it hasn't changed in years.
Yeah.
It took a long, long time in the beginning, and then I rewrote it a few times, and it was really, really bad early on. It was very hard to get it right for the stuff.
Yeah, a lot of edge cases, right? I can imagine. People can
mostly
do and then you have to make it right.
Support these join table inheritance models were very hard for me to get my head around how to persist that, and then it just took a long time because it kind of grew organically. You're coding, you don't know what you're doing.
Yeah. Yeah, well, I'm glad you wrote that instead of me, so thank you.
Yeah, I wouldn't be able to do it today.
You got to be deep in it, right? Comment from Brandon Brainer. Hey, Brandon says, I use SQL Model in a demo project, and it was so easy to use. Very nice.
Good.
Yeah. All right.
I'm glad.
So I think probably the big news over here is 2.0.
Yeah.
Or as you like to put it at your recent talk, the 1.4 inning.
Right, the 1.4 inning. So 2.0 is now the docs for it, which are very early stages, are on the site. In the library tab is a development thing where the development docs are.
Nice. And the current release is the 1.4.
1.4.
It has a lot of these features in there already, right?
Yes, just about everything in SQL Alchemy 2.0 internally is available in 1.4. We did the internals first and added all the stuff so that 1.4 could be a transitional release, so that all the behind the scenes would be getting tested. and people can use the new APIs and transition over.
Right. Is 2.0 going to drop some of the older APIs hard?
Many, yeah.
Okay.
Yeah, so people who have looked, 1.4 has this big migration thing where if you're on 1.3, which is pretty common, you can go to 1.4 pretty easily without much problems. But right, when you're on this thing, we have this whole thing that is kind of inspired by the Python 2 to 3 process, and at the same time tries to not make some of the what I thought were mistakes of the Python 2 to 3 process. So what this is based on is that 1.4 has a environment variable you can turn on in your console, or whatever, called SQL Alchemy 2.0, something like that. And when you turn that on, you're now in warnings mode. You will get all kinds of warnings about all kinds of APIs that either have changed or are going away or use this one or that one. So a lot has happened, but at the same time, the reason that's maybe not as scary as you might think is that all the APIs that are being deprecated are APIs that I've already taken out of the docs years ago. Like the APIs that I've been telling people for years, don't do that anymore. We're not going to do that. So it's a lot of old stuff that is not what we featured in the docs. Like basically the things we're taking out 2.0 are things that have annoyed me for years. And there's a few changes in 2.0 that are, a little more like boom, like we changed how the engine is auto begin instead of auto commit. But it's 2.0 is basically going to be, I think, better. It's in line with this whole notion of people are appreciate more explicitness when things are clear. So 2.0 is going to remove a lot of implicit stuff, a lot of 5 ways to do the same thing kind of patterns. It's going to narrow you down into like one or two possible patterns for things.
Yeah, that has been a thing with SQL Alchemy, right? There's a lot of ways to accomplish stuff. Yeah.
Yeah, because I came from Perl. I'm sorry, I was doing Perl. It's still the case that there's more than one way to do things. You can't really get away from that totally.
Yeah. Well, often there's I want the super simple, easy way, just call an ORM method, and then we got to rewrite the select statement of this store procedure type. There's usually a backdoor type of thing in the database world that has to happen at some point, right?
Yeah, store procedure is a pretty dramatic example. But yeah, these days the way it is that when you write your code, it's going to be clear where the SQL is being executed, where the I/O happens. I mean, in many ways, it actually was inspired by Async I/O, where I had been tweeting a lot with people into Async I/O, which I'm a little skeptical of it. At the same time, what people appreciate about it is that it can show you're very aware of where the actual message to the database is happening. This is where the message gets sent out. Here's where it comes back.
When you say await, now it's happening.
Now I think that's a little heavy-handed, but at the same time, I appreciated that notion. So with 2.0, I tried to work with that idea that we want to make it very clear. Here's where you're making a SQL statement. Here's where it's executing. Here's where the results are. And then also, here's where the transaction is. And those are actually the biggest changes, that you're going to know that you're in a transaction. You're going to know when your transaction ended, when you're going to know if you committed it or if it just rolled back.
Yeah.
And you'll know. And the code is going to be a little more verbose than SQL Alchemy 0.1. But people are already writing code that way, because now that I've seen many years of people writing code, what
like,
people
I really
don't
want to know when this happens, so I'm going to be super explicit about it.
People don't want they don't want excess bells and switches that are that don't seem to have any purpose. But if your code is clear, being able to read the code and the intent is as clear as you can get it, without, well, this just does that, and we just know it does that. That's kind of where I'm trying to go. And I'm somewhat freed by the fact that I know people are more tolerant of step A, step B, step C.
Sure.
Being
a little less magic, yeah.
Yeah, people are okay with that now. They weren't okay with that 15, 12 years ago. People are like, that's too much typing, so sure. It's good.
So I want to talk about this migration thing, like what a person does to go from a 1.3 application onward. But I think that's getting a little bit ahead of ourselves. How about we talk a little bit about, what are the major features coming in 2.0?
Well, first of all, obviously we're finally to Python 3 only.
Yeah. What is it? 3.6? that has a minimum?
We're going to make
version?
it 3.7.
3.7. Okay.
3.7. Yeah. 3.6 is EOL. So in a month or two.
Yeah.
So
no point to do that.
Yeah. Just today, or I didn't merge it yet, but like we're ready to merge this gigantic Garrett review that's going to take all the Unicode conversion crap out. That was all Python 2. I mean, Python 3 having native Unicode is tremendous for us because all the DB APIs do the Unicode now. It was the new API. So yeah, we have this new SQL caching system that I've talked about a bunch in some of the talks I did recently.
Yeah, tell us about that a little bit.
Yeah, that's in 1.4. So
is that like compiling the SQL statements and then like caching those results, or what are we talking about here?
It caches so when you run a SQL Alchemy statement, we have to take your Python code and make a string out of it, which is the string we send to the data. We also have to look at that thing and figure out what kinds of results are we going to get back. Are we going to get strings and dates and integers and floats? And then for those strings and states and floats and whatever, do we have to do any processing on the rows? We want to have that all set up because if you get 10,000 rows back, you want to make all those decisions up front so that when you run 10,000 times, everything is as fast as possible. Everything is already figured out. When you do the ORM, that whole process becomes like way more complicated. There's way more going on. There's eager loaders and there's more fancy kinds of types. We might be taking columns and putting them into an object. All of that stuff is time consuming. And it all now in 1.4 lives behind what I call the cache wall, which means when the caching is working, which it seems to work, it's only going to do that stuff once for a statement that's been cached. So when we run your statement, we're going to do a process that's still a little pricey, which is to get a cache key from what you typed from your select.
You got to determine some sort of unique hash type of thing out of it.
It's actually a gigantic tuple right now, and maybe it'll be a hash in some other release. But for now, it's a giant tuple because Python's pretty good at that.
Yeah.
It's cheaper than doing the whole compilation. And then we get the whole compilation from a cache if it's there, and if it's LRU cache. So if it's not, we make it. And it allows us to put more bells and whistles into the compiler. We have this thing where it will now detect if your statement will produce a Cartesian product, meaning you have joins between tables that are not linked together. And we have all kinds of other fun things the ORM can do that take a little more time to compile, but now they're behind a cache, so the performance is not really impacted too much. And so that's exciting stuff. And we're going to be looking into 2.0 to start using Cython to speed this stuff even more. SQL Alchemy for many years. Yeah, SQL Alchemy for many years has C extensions that we wrote as C code years ago. We're going to migrate those to Cython so that we can more quickly add new Cythonized code for different sections to speed up how those cache keys get built.
Yeah, it's one thing to say we're going to write some big chunk in a C layer. It's another to say just that loop. Could that loop be C?
Yeah,
right? Like, and with Cython, you can kind of just do that.
You can do that. You can do it quicker, and without have to worrying about all the memory reference counters. C code in Python is pretty tedious. Yeah, I'm not really a spectacular C programmer anyway. So
also a lot of people who might want to come contribute are probably not C developers; they're Python developers first.
Yeah,
and
so Cython is pretty cool.
Yeah,
Cython is because you can really, if you just do Python, you can do it. It's just like a strict Python. It's pretty neat.
Yeah, it is.
And we found that some of the Cythonized versions of the functions are actually faster than our C code.
Really?
Strange.
That's pretty strange.
Faster, because Cython, the people that did Cython optimized the crap out of it. They know all these very esoteric Python C API things that, like, literally we have, our C code is not a lot of code. It's like, it's like a few hundred lines. It's like, we'll call tuple get item or whatever it's called. Cython has some, well, if we do this and that, then it's faster. And it actually is. I can't give you detail on, because I don't know, but like we did benching and Cython was actually faster than raw C code.
Yeah. I remember more naively way back when hearing, people used to say, well, if you want it to be fast, you have to write an assembler. And then you can use C if it's not going to be that fast. You can right.
That's a different kind of fast.
Right. Well, what I was,
to be clear.
What turned, of course, but to be, well, the interesting thing to me was there was this switch when the compilers got good enough that you probably were slower writing assembly for most people, right? And I feel like the thing you're describing here is kind of like that transformation. Like the compiler understands the whole system better than if you were to try to do it yourself at the same level.
Yeah. They found, they've apparently, I don't know the specifics, but in some cases they have figured out ways to make it even faster. So there's no reason to not use Python.
Yeah, you think of what people are doing with Python, right? Like they're running on supercomputers doing huge calculations that take, so they have a strong motivation to make it a little bit faster here and there, right?
Yeah, I mean, right. Look, here's the thing about Python. Python is a high-level scripting language. It's interpreted always. So it's already not, I don't want to say that, but like, if you really are writing like, high-frequency trading software, you probably want to use something else like Rust or something. Python's not really that. It's a lot of things, but it's not like, high frequency trading speed demon type thing. You can make it do that. But
once you start wanting it to be sub millisecond, you might want to start, but other than that, you're probably fine.
Yeah. It's not going to, I might be wrong. It's not going to control the rockets, but I guess maybe it does. I don't know.
Yeah.
It doesn't have to be that. It's so useful for so much stuff that,
absolutely. Okay. So that's really cool. So you're thinking about switching some of your C code over to Python, which is really interesting. And I didn't see that one coming. That's awesome. The cache layer is cool. So that way, if I call a function and in that function, I do a query statement in the ORM, the first time that's expensive. The second time it's not free, but less expensive, right?
It's much less expensive.
Like much less. Okay.
Yeah. What we haven't sped up yet, and I mean, I've been speaking this for many years, is when you fetch rows from the ORM to create the Python objects that are your classes, that's still more expensive than we'd like it to be. So if you're fetching
one of the most, that's super expensive in ORMs and ODMs. If you select 10,000 rows out of a database, it's probably the serialization or deserialization that's the cost, right?
Completely. And I've made the loading way, like I spent years and years making it way faster by doing that whole thing where we pre-calculate everything up front. Every like loader, we're not going to, like every time you get a row, it's like zip, 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 zip. We have these little callables set up, but still just to make the object, just to make a new class in Python is expensive. It's pricey. So still work in progress, but the caching will not speed that up. It'll speed up the overhead per query.
Sure. Which is still like every area you can speed it up is great. Danielle out there says, Python is also a great choice to forget about ref count in Psycho PG2. It took a while to find all the small leaks.
Yeah, ref counts are tough. Ref counts are tough.
Yeah.
I'm pretty proud of myself that I did figure them out to some degree. They're not as hard as malloc and free, but the ref, it's kind of an esoteric set of rules to ref counts.
While we're down in the internals, let me ask you this. If you've thought about this or experimented with this, one thing as I dug into Python's memory model that I found to be really interesting is when you create, you have GC, the GC module, you can say GC get thresholds or set thresholds. And the thresholds tell you what will trigger a garbage collection, not reference counting, but a cycle detection type of thing, right?
Yeah.
The defaults, at least last I looked, I haven't looked in 3.10, but in 3.9, it was 710.10, which means 700 allocations. And then for every 10 Gen 0 collections, there's a Gen 1, and every 10 Gen 1, there's a Gen 2 collection. That 700 means if you allocate 700 more classes or dictionaries or tuples or whatever than have been freed, a GC will run.
Yeah.
So if you select 10,000 rows out of a database, how many GCs are running? I mean, that's a lot, right? That's like
it depends on what you're doing, because if you're taking the 10,000 rows and putting them in a gigantic list, then it's not GCing much at all because you're putting it all in a gigantic buffer. You're going to watch the size of your process grow.
Right. But you're not freeing any, and you're not ref count freeing any either, but you're allocating 700 more.
Yeah.
I think that might trigger 14 GCs, unless I'm understanding it wrong.
You would know. I don't know anything about. I wouldn't know. All I know about GC is that it's going to happen.
Yeah. I mean, the reference counting stuff is super straightforward, but the GC side. So I've always thought about this around the database, even if you're just getting dictionaries, not ORM classes back.
Yeah.
If you're selecting a whole bunch of stuff, not only are you doing that serialization layer, you're also incurring a bunch of GC because it's trying to preemptively run around and look for cycles that might have been forming.
Right. Well, one thing you can do is make the code so that you don't have as many cycles. And we actually do that. We've had people post issues related to this. So I said I don't know much about GC. I do know that if you can reduce reference cycles, you will have less of these asynchronous GC runs happening. So we had someone specifically came to me with a whole lot of use cases where he showed when you run this little code, like all these GCs would happen. And we went in there and got rid of a lot of cycles. So we actually have a test suite in test/AA profiling test mem usage called cycle test, something like that.
Okay.
And they're all these little whiz bangs that run like make a session, then close it, do this, then that, do this and that. And then it will runs it in a harness that actually is counting what GC is doing. And it's asserting that there's only like 5 GC calls and not 20.
Right. Yeah, that's fantastic.
We have a lot of that happening. Yeah.
Interesting. So, yeah, it's cool that you're thinking about it. I mean, on one hand, this is an external thing, so you can control your data structures, but you can't totally control what people set their GC to do. But anyway, it's just something that I always think about when you're creating lots of these ORM things, because a lot of the signals to the GC are like, oh, I got to get busy, but you're not even like that's a single call to SQL Alchemy, and I'm just waiting. There's nothing else I can do to get out of the way. You know what I mean?
We've just been around for so many years, and people have come to us. So we have all kinds of mem usage and C profile stuff in our test suite to make sure the call counts don't grow here, to make sure we don't do too many GCs. We try to work on that as much as we can.
Yeah, cool.
Ongoing.
So I would say one of the things that makes me more excited than most of the other stuff here is probably the async support that you have going on. That's you want to talk a bit about that?
Yeah. So when I was doing 2.0, I thought I wanted to be kind of compatible with how Async IO works, because I figured I would eventually do an Async IO API for it. But then I suddenly had this idea: why don't we just do the Async IO thing? And we use this library called Greenlit.
Okay. Yeah.
Can we just take a quick break? Because I 1 second.
Yeah, sure. No problem. Go ahead.
I'm just going to stop here for a second and be right back.
Thanks everyone out there in the audience for all the good questions. I'm gonna have to run some of those GC examples and count it. I asked that because over on Talk Python training, over here we have, as you imagine, sitemap.xml, which is all the sitemap stuff, but tons and tons of stuff. You see how big that scroll bar is? It's massive. When we were loading that page, we were getting 77 garbage collection cycles. And we had to change the GC stuff, and we got it down to 2, and it made the speed of the site so much better. Now we're not using SQL Alchemy, we're using Mongo Engine and MongoDB, but the principle is identical. So it's interesting, but still I got to check into it for SQL Alchemy. Pretty interesting stuff. Thanks, John. Really glad. Yeah, Mike has some fantastic insight there, for sure.
We're back.
And sorry about that. No worries. I was just sort of riffing on some stuff, some follow-up stuff there. All right. So async. Where's a good example that I could pull up on the website to show like using a query?
There should be an async IO. Okay. In ORM examples.
Yes, exactly.
Yeah.
Let's see. Oh. ORM examples. Okay.
You were just there a minute ago.
Yeah. I'm there.
Do we have async IO?
That's what I was thinking. Let's see, Jason.
Oh,
there you go. Async IO integration. There we go.
So the way the async IO works is that SQL Alchemy has a blocking API.
Yep.
We call DB API execute. It blocks. It comes back. Usually, the way you want to make that kind of thing work in an async non-blocking context is you have to throw all the stuff into a thread pool. You probably don't want to be in the wiki. This is more old stuff.
Okay.
Yeah, like that one. click on async ORM at the top. That one.
There we go. This is the one I was looking for.
That's the most basic. Yeah,
this is the one I wanted to show people. Yes, not the session one, but the ORM.
Yeah, this is ORM. Okay. So what's important here is that the notion that we 2.0 style has the thing where there's a very specific place that execute happens, because like with the query object that SQL Alchemy session.query, you could say query.all, query.1, query.first. I didn't want to have all this await this, await that, await everything. Mm-hmm. With the new API, it's just, which is really the old API, it's await execute, and then you get your result back, and then the result is buffered. And the way this works that changed the whole async IO equation for SQL Alchemy is that this is not a rewrite of anything. This is a layer on top of the completely blocking API stuff, and it does not use threads. It uses Greenlit. When I went to look at what Greenlit actually does, a Greenlit is compared to a thread, but it's kind of not like it's like a thread. But when you see what it is, it doesn't really feel like a thread because it's a little thing with code that you can context switch somewhere else. So
it's more like generators than it is like threads. Like the weirdness of generators skipping around. Yeah,
exactly. So the way Python async IO has that await keyword, the await is your context switch in async IO. Now, I wanted the internals of SQL Alchemy to work in this context switching way, but to integrate with await. So we basically made a Greenlit wrapper that emulates await without actually using await. So you're able to take SQL Alchemy's blocking internals, which ultimately go out to when you use SQL Alchemy async IO, you're going to use a DB API. Actually, it's not DB; it's a database driver that is itself also async IO. Currently, here goes my code. Async PG, AO SQLite. There's a async my, and also there's one. Oh, I can't remember the name of it. Wait, I can't remember the name. I'm trying to get Danielle to Psycho PG3. I was teasing Danielle because he's on there. There's going to be a Psycho PG3 that we're also going to support that does async IO for Postgres. So you have the async IO driver. SQL Alchemy then adapts the await calls into its synchronous thing using the Greenlit thing. And then on the outside, where you see on the screen there, is you have async IO stuff. And when I actually talked to some of the people that were involved with async IO in Python, they explained to me you could do it the other way too. You can have a synchronous API that calls into an async middle that goes back out to a sync API. And that's actually kind of easier to do. But since SQL Alchemy was already written in sync blocking style, we kept it that way.
Right. It's a lot easier to wrap a async shell on something that's 15 years old and polished. Right. Then just say we're going to do the inside all over again.
Yeah. And the thing with async is that there were some SQL Alchemy based things on GitHub and whatever that were basically taking our engine and connection and rewriting them as totally brand new async IO things.
Yeah.
And I always thought, I'm like, that's not, you can't maintain that. It's like you're taking our code, taking about 30% of what it actually does and putting it up. And I was like, that can't work. There's got to be a way to get green, because I had used G-Event and Eventlet a lot. And I'm like, okay, I know Python can do this. I know it can context switch without using await. I know it can do it. I just had to go in Greenlit and read the docs, and I did that.
Yeah.
So
yeah, that's really cool. I'm super excited to see this because it opens up using SQL Alchemy with some of the other frameworks that really leverage it. For example, Fast API, but there's plenty of others as well, right?
Yeah. Another cool thing about async IO was that when I did the SQL Alchemy 1.4, which introduces this new query ORM interface, but keeps the old one, which is not going to go away because there's just too much code in the old query interface. But for async IO, it's totally brand new greenfield development. So I said, with async IO, you've got to use our new API. That automatically got a lot of people to be testing the new way of working and got us to get people, because the one thing that makes libraries really good is when a lot of people use them and find problems with them and add use cases, and the library becomes mature. So the async IO thing has been enormously helpful to bring a lot of people to SQL Alchemy who would not have been there. A lot of people who were probably going to leave SQL Alchemy stayed. And people using
SQL Model probably wouldn't have been based on SQL
Not
Alchemy.
at all. Yeah, exactly.
Because obviously Sebastian needs that to integrate with Fast API, and the async is a core element there. Out the audience, Daniel says, I wonder if other drivers are moving to expose native async interfaces themselves. Time to go back to DBSig.
DBSig, yeah, that's the database special interest group.
Yeah.
Sure. Daniel can go there. I've not had much success when I go to the SIG to suggest things.
Yeah. Let me talk about this async API a little bit for folks who are probably familiar with the SQL Alchemy's traditional API, because there's a couple of things that stand out to me here. One is, let's start simple here. One is you have this concept of creating a select statement and then executing the statement, as opposed to like a query of a dot filter. So there's this sort of this statement model that you build up. You want to speak about that?
The original, the SQL Alchemy with query really is 95% the same statement model. It's just the statement has the fetcher, the getter, the result fetching method stuck on it.
Yeah.
And you know, when query came out, that was kind of a historical thing. The original idea for SQL Alchemy was that there was only going to be the select object, and then you would use select object with the session to get results. And then it wasn't really done very well, and it wasn't very flexible. Right. So people were coming to me with, well, why don't we do this generative builder thing? And that's kind of what happened, because I was a little bit rudderless in those days. So we had query, and it took me quite a long time to realize, wait a second, query is basically, once query got much more fancy, it started out as very simplistic. Only can query for one object and do this and that.
Right.
As I had to keep adding to it, it became clear that I was rebuilding select.
They met in the middle, huh?
Yeah, that like I'm just rebuilding select in exactly the same but slightly different way. And that bothered me for years. So with 2.0, I finally took that on and did a really, really long, difficult refactoring to take all of the guts of ORM query and put it into a different module called context that you don't deal with. And when you get the select object you see there, that indicates the exact same intent as query a options filter. And they both go to the same backend that does all the ORM figure it out stuff that's a little more elaborate to come up with the SQL that will be sent to the database.
Yeah.
It was one of the biggest refactorings I've ever done, and it was quite stressful when it seemed like I was hitting dead ends. This is not going to work, you know?
Yeah.
It was tough.
I can imagine.
Yeah,
this is cool. So basically the query of class dot, that style is going away, right?
It's never going to go away because there's so much code in that style that it's basically not, when you go to the website, it's not going to be in the tutorial. It'll be in reference docs. So people that deal with the code can deal with it.
It'd be in some sort of middle ground where it's not fully deprecated, but it's not promoted either, huh?
It's called legacy. We've had different systems that stay in legacy for many years.
Sure, makes sense.
And query
there's so much code written that way. I totally agree.
Yeah, I probably would never take it out.
Yeah.
But what I did do is when I do that, I try to make that code written such that it's all by itself. And it basically, what query does now is it makes that select inside.
Right.
And sends it off. So it's what you call eating your own dog food. It means that the alternate API uses the real API internally. So you're testing it either way.
Right. Going back to our patterns talk, it's like an adapter for the select pattern. Yeah. Okay.
Yeah.
API. Two other things that stand out here. One is you create a session maker traditionally, and you create a session by calling it. Here you have an async session maker, right? To create them.
Yep.
That's one of the differences. That's not super different, but the other one that is interesting to me is now these things are context managers.
Yeah.
When I used to work with SQL Alchemy, traditional ones, I would create a class called a session context just so I could do this in a with statement. And here, obviously, it's an async with statement, but that's just the async aspect of it.
It's in the sync aspect too. I should mention that when SQL Alchemy in 2006, we were in Python 2.3. There were not context managers. They didn't come out till Python 2.5.
Right. So you can't integrate with them if they don't exist in your API.
So I didn't. So nothing was based on that. So SQL Alchemy 1.4 and 2.0, as much as possible, completely support the context manager model. And the docs and the tutorials, if you look at the new 1.4 tutorial that's on the site, it's all about context managers, and all the try, excepts, and writing your own thing should go away. You should use context managers now. And what you see there with the async pattern, I've made it so that if you're using all the new APIs, the context manager pattern with the engine and connection in core is mirrored to the context manager pattern with the session and the session maker. Nice. And then that also mirrored in the Async IO API. So there's 4 different APIs. There's core and ORM, sync and async, and they all should have, as much as they can, the same. See the hands. This means code. They have the same. As much as possible, they should have the same context manager patterns. And we want you to use context managers for everything now, for any kind of blocking of, and that's also how we can improve the transactional model, so that you're really working the transaction all the time with the core, because it's not a burden, because you have context managers.
Yeah. So one of the things I see here, I want to ask you about 2 bits of code, and then take another question from the audience. So you have a with session.begin, and you do some inserts, and then you don't say session.commit. So the way this works, I'm presuming, tell me if I understand this right, is if it makes it through the with block without an error, it commits. If it makes it through the with block with an exception, it just doesn't commit, and effectively rolls it back.
It does a rollback. Yeah.
Beautiful.
That's correct. Yeah, and we've had the begin context manager for a long time. It's just it wasn't totally consistent everywhere, but we've had that for a long time. But now I've made sure that all the opening and closing of a resource and the begin commit of a resource are consistent. And also there's always a way that you can open the resource and begin commit in one line of code. Also, the session maker has a begin on it now. And you could do that. Yeah.
So the other thing, I'm super familiar with execute.
Yep.
But then you also have stream, which looks real similar.
Sure.
What's the difference there? Stream
is async IO only right now. Stream is because it's important in many cases to get a result that's doing async streaming. And when you're doing async streaming with async IO, you've got to have the await keyword. So you can see the result object returned from session.stream is called an async result. And all of the methods have the async annotation on them, so that you see it's async for A in result.scalars.
Oh, I see. So the things you interact with, the subsequent functions, are themselves all async as well.
Yeah, okay. That's cool. And what that will do is that will try to use a server-side cursor.
Yeah, that's what I imagine. That's cool. Yeah. Instead of trying to pull it all into memory, if you got 1,000 rows back, you could start pulling them more generator.
Right. When you use the server-side cursor, you actually are genuinely not pulling everything into memory first. When you use the buffered result, you're getting everything into memory at once, which is normally okay for smaller.
Yeah, most of the time it's fine. But if you want a whole bunch, or you're flowing it on word, anyway, a lot of cool stuff there. So I think we'll get short on time. Mr. Hypermagnetic out there asked, does SQL Alchemy support paginated results? That also leads us towards a little area I want to focus on, just a couple of things as well. So maybe address that first.
Paginated results is kind of one of those things that seems simple, but it's more of a quagmire than you might expect. There's different ways to do paginated results. The way we all did it years ago was we used these functions in SQL called limit and offset, where limit will give you like 10 rows at a time, and offset will start your result set in the middle. Once we work with bigger databases, we all realize that offset is terrible, because offset will actually get the whole result set and scroll through it. It does it on the server side, but still very slow. So nowadays, when you do pagination, you want to have some kind of approach where the query you're doing is looking at some data in the data, some row in the data, some column in the data you're querying. So like if you were paginating by date, page 10 would be where date is greater than this date that you know from the previous page you just got. That's one way. Another way is to write SQL query that do this thing called window functions, where you can kind of figure out all the date or this whatever thing ahead of time. Pagination implies of that approach implies that you have, actually of any approach, implies that you have an order by something. So it's hard to make pagination be like this result here, result.scalars, to say .paginate. That's not really, I mean, you can make a very crappy version that does that, but it's not really, it wouldn't really work that way. There is I should say there is a method in the result called partitions that will give you chunks of a result at a time. It's not quite the same as pagination, because pagination is stateless. It's usually for web applications where you're going to get a certain page of a result and then show them a web page, and then your whole SQL is over. And then you're going to come back to that SQL later. So we have features built in for partitioning of a single result set so that you get chunks of it at a time, which is helpful. Pagination is something you need to go and look. There's some, I think maybe SQL Alchemy Utils probably has some helper functions for that. We have some recipes in that wiki page that I told you to leave. There's actually some recipes for pagination there. I don't think pagination is like a turnkey. It's got to be kind of customized, and people will write pagination frameworks, and they're complicated and they're hard to do. So we leave those as an exercise for the community to do. But we do have some recipes for that. Yeah.
Yeah. Thanks. That's a great answer. Okay. Now for the last thing, I wanted to talk really quickly about this list from Dahlia called Awesome SQL Alchemy. It's one of these awesome lists that covers all these SQL Alchemy things like data structures and types. And I'm just throwing this at you, and neither of us have a ton of experience with a lot of these things, but I thought it'd be fun to just kind of go through them, some of the nice or interesting things that I've run across here. So it's a way to kind of wrap this up, like some extras. All right. So one of them is SQL Alchemy Continuum, a versioning extension for SQL Alchemy. Yeah. So
it's probably based on one of the recipes that we have in the source distribution, probably. Versioning, it says the first line, SQL Alchemy already has a versioning extension. And the extension is very limited. That's correct. Everything he wrote there, everything they wrote there is correct. I had some jobs in the banking industry where I was doing SQL Alchemy, and we had some need to version rows and data. And we
need to know exactly audit this and when has it changed, and how do I go back?
There's different models. You can either take the rows as you get them and put them in an archive table, or you can do this thing where you never update or delete a row. You just insert a new row, and you've got kind of a temporal version scheme. I have some recipes to do that in the example section because I did them at a job, and I believe Continuum builds upon those to make a more robust, well-supported thing. I don't know. I've heard of Liquid Base. I don't know.
This is out of my world. I'm not a Java person either. Sorry, but
maybe it might be like that. Yeah.
All right, here's another one that I ran across from that SQL Alchemy awesome list is SQL Alchemy Enum 3.4. I'm guessing because it came from Python 3.4. This package provides SQL Alchemy type to store values as standard enum.enums. Because a lot of times what happens is those things get turned into like numbers or other weird things. Yeah. And here they get a little more type information, right?
This might be obsolete because we do support regular Python enums in our enum type.
Yeah.
We didn't at first.
This is looking like it's 7 months ago. I don't know.
Well, if someone's using this, they could stay because there are some enum features I've been notified that we don't do exactly the way. There's some extra features that I forgot what they were, but there are some things that enums do that we don't support. So this probably
adds that on,
does that better, enums are really a pain in the butt. the data types.
I know.
The Python side's good, but the database side is.
It's always some sort of hack. Alembic, I mean, that's pretty well known to people, but that's obviously important because you've got to keep your database and your models pretty closely in sync, right?
Yeah, so we maintain Alembic. I wrote Alembic years ago as SQL Alchemy Migrate was kind of not really holding up to what we were doing. SQL Alchemy Migrate is part of OpenStack now, and I actually have maintained that a little bit as well. But Alembic was meant to be more of a bare bones, straightforward, not too fancy tool. It has become fancier. And people that use it and get what it's about like it a lot. It's never going to be as cool as South for Django. I mean, maybe an Alembic 3, but I don't. That could happen. It's not as automated as everybody would like. It has a system that it will look at your models, it'll look at the database, and what we call auto-generate your migrations. But we don't guarantee those migrations are completely perfect. You've got to go and look at them and fix them, which I still think it just did 95% of the typing for you, of the work for you. That's what it was meant to do. So Alembic is very, very solid.
It's helpful because it works in that realm of, like, that's the area of SQL I know less well, the DDL and that drop.
Yeah.
How do I drop a table or a column and then re-add it under a different name without losing data? Like, all that kind of stuff can be tricky.
Yeah, DDL is where a lot of the database vendor specific stuff is exposed, like all these crazy keywords and data types, and it's less declarative and more imperative. And so for Alembic, we just provide a model to create your migrations, and it's been working pretty well. It's got a lot of features now. But it's, again, a tool where if you don't know what DDL is, you're going to have a bad time with Alembic. You should learn what database migrations look like in alter table, alter column, and kind of know what that means. And then Alembic will be pretty smooth. And there actually are extensions for, I saw it wasn't on that list. There's an extension called Alembic Utils, which are extensions for Alembic for Postgres that also build upon some recipes that are in these docs here. And I recommend looking at that too.
Cool. All right. There's a couple we can go quick on. There's one for talking to Amazon Redshift as a provider. That's pretty cool.
Yep.
There's Form Alchemy, which
is it still maintained? This is an old one. Form Alchemy is, you see, 12 years ago.
Oh yeah.
So it's old.
It's old. Maybe it still works, but let's leave that.
It probably still works. It looks
probably.
Like
HTML hasn't changed since then, just styles and CSS on it. All right. GeoAlchemy is pretty popular for people doing geospatial work.
Yep. So there's GeoAlchemy and there's GeoAlchemy 2. I'm not sure of the relationship, which one is which, who works on which one. GeoAlchemy seems like it might not. I'm not sure how much it's maintained. I think it's maintained. I would like it to be much more well maintained. I think it supports. It's pretty Postgres centric, but there are Geo things for SQL Server and Oracle and MySQL.
Yep.
I would like to see that stuff supported as well. GeoAlchemy, I don't hear much about it, but I think it's a good project.
Yeah, cool. One for some growth, perhaps.
Yeah.
SQL Tap, a SQL profiling and introspection for applications using SQL Alchemy.
Wow. Cool.
Have you seen this?
Probably not.
I have not seen this either. This is so when you do a request, I think what it's doing, it stores what the page did. So it says here, there's 12 queries. It spent like 20 milliseconds. And then you click on each one and it'll show you the select statements and like the actual SQL.
So it's probably profiling from the client side.
Yeah. I think so. Yeah, I think so.
That's nice. Because you can, if you're just timing it, that's cool. I wonder if it does things like explain.
Yeah, I don't totally know, but it looks like it has a WSGI integration, which is cool.
Yep, cool.
This is another one related, sort of that helps. It's called N+1.
Oh,
and, N+1.
That's cool.
Is a problem that many ORMs run into when people don't realize they're doing lazy loading and they don't do a join. And it can be super indirect. Like, here I got a query of a list and I sent the list off to the HTML template, and the HTML template did a loop and talked about some property on the thing. And then there's bunch of more database queries or something crazy, right?
Yeah. Interesting that it seems to work for multiple ORMs.
Yeah. SQL Alchemy,
so
Pee-wee,
I guess
Django.
it's streaming, maybe just taps into the APIs of all those different tools.
Yeah, probably someone's added a layer for each.
Yeah, I guess you could do it in a kind of a distant way heuristically. If you want to see the same query to the same table over and over again, maybe that's what it's looking for.
Yeah,
where I could do that without necessarily looking at SQL Alchemy saying lazy load got called. If it just looks at the SQL, there's probably ways to do it, but that's kind of an intricate problem. But that seems like a really useful tool if it works.
Yeah, it does. And also I saw in there, we'll just close it out with this. I saw in there they mentioned the Pyramid debug toolbar, the Flask debug toolbar, and the Django debug toolbar. And I can't speak to Django. I don't think I've even run the Flask one, but the Pyramid one has you can open it up and say, what were the SQL Alchemy queries of this page?
Right.
And actually see how many queries. And if you're on a page and it says, look, there's 51 queries, and you're like, I thought I did one. What just happened? How did I get 51?
Yeah.
Like, well, you got 50 elements in an N+1.
Yeah, the debug tool, I haven't really worked with it, but we have a lot of people dealing with it, or we have to fix issues related. I don't actually write any web applications anymore.
Yeah,
I just do this, so I don't get to do that. I don't get to see that stuff.
Awesome. Really cool. I also don't use them very much anymore either. I find like I don't need that support as much as I did in the early days, but I do remember them being quite valuable.
Yeah.
All right, Mike. Well, there's more stuff we could go into, but what a cool conversation. And thank you so much for releasing the 2.0 stuff, for adding the async support. It really opens up a lot more use cases.
Yeah.
I think that are going to be interesting for people. So yeah, it's fantastic.
Yeah, my pleasure. It worked. The async worked out really well. I'm really happy about that.
Yeah, great. Now, before you get out of here, let me ask you the final 2 questions. You kind of alluded to this already. If you're going to write some code, what Python editor do you use?
I'm on VS Code right now. I was on Sublime for a long time. Years ago, I used TextMate. I do use VI and Vim a lot. But if I have like lots of windows open, right now it's VS Code.
Yeah, fantastic. And then notable API package, anything come to mind? I mean, we kind of threw out a whole bunch, probably.
Did I put anything? I'm gonna click to I didn't put anything down.
I'll come up with some later. Out of the list that I threw up there for you. Tell me, like, the awesome ones. Which one stood out the most to you?
Oh, that N+1 thing looks really interesting.
All right, awesome. So N+1 with the plus spelled out, and the 1 also spelled out.
Yeah.
Cool. Yeah, very good. All right. Well, final call to action. People have a bunch of SQL Alchemy code that they've written, but it's probably for the older style. It's probably not async and so on. What do you tell them?
We have a brand new tutorial on the current website. If you go to just docs.sqlalchemy.org, on the left side, it'll have this 1.4/2.0 tutorial that kind of represents SQL Alchemy all over again, using all the newest concepts. I would look at that and just get to know it, and also point out problems. Yeah, this is the new tutorial. So this supersedes the old tutorials, and it's going to talk about core and ORM at the same time. So this is a complete brand new rewrite from the ground up. It took many weeks to do it. And then there's also the migration guide. Yep. But if you go through this tutorial, you really see what the new way of working is supposed to look like, and what the idea is, what's supposed to be. If you read the tutorial and assume you don't have any SQL Alchemy code, assume you're just learning it from scratch, see what it's like. See, wow, this is different. Or you might see, oh, I never knew that was like that, because it really tries to represent the library from the, first principles, so to speak, up to the ORM stuff.
Yeah, fantastic. All right. Well, I'm excited about all these new features, even the embracing of context managers everywhere. It looks great to me. So thanks for being here, and thanks for sharing this with everyone.
Yeah, my pleasure.
Yep, you bet.